Hello everyone, myself Rajiv Raj Singh, Narayana Physics Faculty. So today I am here to discuss some special topic on the demand basis, null point in gravitation. How to calculate null point in gravitation. Yeah, I don't know and I don't care you are my student or not, but if you want to share your doubt, your any kind of topic, then you share. Whenever I will get the time, I will give you reverse video, right? Thank you. So see, what is the null point? So first of all, we will understand its definition, its physical meaning, then its calculation, mathematical expression. So first of all, definition, what is the null point? So definition is here, very easy. The point at which net gravitational field intensity becomes zero, because null point you will get in electromagnetic also, in magnetic, right, or you can say magnetic material. In that also they will teach you null point. So null point in gravitation, because of that I wrote here null point of gravitation, the point at which net gravitational field intensity becomes zero. Such point is called null point. Okay, so this is its simple definition. Now coming on its my dear students, see, I assume we have three masses. I assume that may be lot of masses, maybe more than 3 or less than 3. So I assume here three masses, M1, M2 and M3. Due to all these three masses, gravitational field, right, you can say gravitational field GP, gravitational field at point P is 0. Suppose that, just assumption I am taking some. How many masses? Three masses. Due to these all three masses, assume gravitational field at this point becomes 0. Then point P is called, null point. Then point P is called null point. If you will keep any mass here, that mass will be without any force. I cannot say it is at rest. If you will keep in motion, so it will move. If you will keep at rest, so it will be at rest. But we can say this will be without any force. So F net becomes what? 0. If F net 0, so net acceleration is also 0. So if we will keep the mass here at rest, they remains at rest. If we keep in motion, so they will continue to motion. Now we are coming to the points how we will calculate null point. See, just we are going to calculate first case, calculation of null point between two masses. Suppose that we have mass M1 and another mass M2, and distance between them is r. So you have to calculate null point. So if we will study electrostatic, so I have already explained in the electrostatic how to calculate null point. So in electrostatic I told you make three regions. I already explained there, make three regions. So suppose region first. This is the third region. This is the second region. So I told in the case of electrostatic check. First, second and third case, but here I am not going to say check in first and second, because always null point will be here between M1 and M2 always, because this is an attractive force. Gravitational field is always attractive in nature, so the null point 110% will be between two masses. It cannot be here, but in the case of electrostatic, yeah, it is possible, that may be here, because in that case I taught you check all the three cases. Okay, now I am going to give you proof why null point never exists here. See, if I will take any point here, suppose that point P, so this mass will be attract to this one, this mass will be also attract. So these two fields are in the same direction. So they will never give you zero value. Similarly here, see, I take one more point here. So due to this one, this will attract, so gravitational field in this direction. Due to this one, this is also attract, so in this direction. Again here, both are in same direction, so field intensity this side never will be 0. But check here, check this point here. Suppose that I assume from here x distance, so this become what? R minus x. Anybody? So here you can check, this mass will attract to this one, so one gravitational field in this direction, and this mass will attract in this direction, so another gravitational field in this direction. It means, my dear, at this point you have two gravitational fields in opposite direction, and gravitational fields are vector quantity, so maybe they will cancel to each other and you will get the zero result. When you will get the zero result, then this become your null point. So from here we got at one point, null point or gravitational point, null point or gravitational null point always lies between the masses. It never will be this side, it never will be this side. But in the case of electrostatic, there may be chance here as well as there as well as here, right? Okay, now going to calculate mathematically. See here. So, you know, here gravitational field will be 0. Here, there may be at anywhere, because I assume this value is x. Suppose x is coming r by 2, so it may be here. Suppose x is coming r by something, r by 3, so maybe x is here. Suppose x is coming 2r by 3, maybe x here. So because I assume take one variable value x. So from here what we can say, suppose that this is the one gravitational field I1 and this is another gravitational intensity I2. So at P, if P is null point, so I net should be what? I net should be 0. So see, if it is in this direction, this one this direction, so I2 is what? Positive I cap and I1 is negative I cap is equal to 0. So I2 is equal to what? I1. Now apply the result, you got the result, minus Gm by R square. You calculated the gravitational field due to any mass minus Gm by R square. So this become I2. I2 is what? Due to M2. So this become minus, see my dear, minus Gm2y. This distance is what? R minus x whole square. This become minus Gm1 by x square. So G is get cancelled, minus minus also get cancelled. Can I write this one? Okay. So this result will coming, so M2y r minus x whole square is equal to m1 by x square. Take this from this side. So this result is coming m2y m1 is equal to r minus xy x whole square. So from here I can say r minus xy x is equal to under root m2y m1. Right? Can I hear this one? Thank you. Now see, you can assume this one something. You can assume this one any constant c or k. So this become root k or simply k. I assume because this is a constant now. M2 by M1 become constant. So I assume constant. So from here you can say this become r by x. X by x becomes minus 1 is equal to k. So here r by x is equal to what? 1 plus k. So x is equal to becomes, my dear, x is equal to become r by 1 plus k. So this is a position of null point. This is a position of null point. And k is what? M2 by M1, I think. Okay, just hold. Now see, basically k becomes M2 by M1, one constant. Yeah, this formula you can use. This is a very, very easy formula. But always keep in your mind this diagram, this figure. This is what? M1. This is what? M2. Here I assume a value of x from M1. In that case, k becomes M2 by M1. Suppose, can I get? Suppose someone assuming that, like this. This is a M1 and this is a M2. Now suppose someone assume the value of x from this point P. So in this case, k becomes M1 by M2. So value of k K may be changed according to the right observer. If you are observing from M1, then this becomes M2 by M1. If you are observing from M2, then this becomes M1 by M2. Just take one example. Have one example. We have to calculate null point between them, right? We have to calculate null point. Calculate null point. See, calculate null point. Okay. So here two masses. One is 2 kg, another is 8 kg. And distance between them is what? Null. 2 meter. You have to calculate null point. So see, if I want to calculate from here, I assume this is a x. This is a null point. So in this case, this becomes M1 and this becomes M2. So x becomes R by 1 plus k. R is what? 2 divided 1 plus k. K is what? Under root M2. M2 is what? 8 divided 2. So x becomes 2y. This becomes 4. Sorry. Yeah, 8 by 2. 4. 4 and under root 4 becomes 2. 2 plus 1, 3. So this answer becomes 2y 3 meter. If you want to calculate from here, then take at the place of 8 by 2, you have to take 2y8. Done, buddy? So this is a method of calculation of null point. Okay, see the next.